Hi students, this is Victor sir from Emmanuel's Pedagogue. I'm happy to meet you on the third session of the Fundamental of Mathematics. Students, today we are going to look at a topic which is called as fractions. Now what is a fraction? A fraction is a number which is expressed in the form P by Q. A fraction is always expressed in the form P upon Q, where P is also an integer and Q is a non-zero integer. Non-zero integer means all integer except 0. So a fraction is any number which is in this form P by Q, where the number P is called as the numerator of the fraction and Q is called as the denominator of the fraction. Okay children, so now see, I will be looking at few examples. For example, say 4 by 5 is a fraction. Is it a fraction? Yes, because 4 is an integer, 5 is also an integer and 5 is a non-zero integer. That means you can take any number in the numerator and you can take any number in the denominator except 0. Because in the last session I have taught you that if any number is divided by 0, it's not defined. In the same way, 2 by 7 is a fraction. You have 12 by 15 is a fraction. These all are fractions. But children, 5 by 0 is not defined. When the denominator is 0, you cannot define the fraction. So it is not defined. So this is not a fraction. Okay children, so you got any number which is in the form P by Q is called as a fraction. You can call the number P by Q as a rational number also. What you can call it as? You can call it as a rational number. Any number which is in the form P by Q can be called as a rational number also. Now children, we'll be looking at equivalent fractions. So you got what is fraction. Children, I want you all to make note of everything that I had been teaching you. Okay, so now we'll be looking at equivalent fraction. What are equivalent fractions? Equivalent fractions are fractions of same value. What are equivalent fractions? They are fractions of same value. The fractions which have same value are called as equivalent fraction. For example, 2 upon 3 and 4 upon 6 are together called as equivalent fraction. So how can 2 by 3 and 4 by 6 be an equivalent fraction? Because when I convert 4 by 6 into its simpler form, say I convert this, my first fraction is 2 by 3, my second fraction is 4 by 6. Say I can divide it by 2, so 4 goes in the table of 2 and 6 goes in the table of 2, right? So 2 2s are 4, 2 3s are 6. That means 4 is divided by 2 and it is converted into its simpler form, which is 2 by 3. That means the simplest value of 4 by 6 is 2 by 3. So 2 by 3 and 4 by 6 are a pair of fractions which have same value. And that is why such fractions are called as equivalent fractions. In the same way, 1 by 2 and 4 by 8 are also called as equivalent fraction, because I can convert 4 by 8 into its simplest form by dividing by the highest common factor, which is 4. So I have 1 by 2. So as these values are equal, these fractions are also called as equivalent fractions. Okay children, so you understood what are equivalent fractions? So equivalent fractions are fractions wherein the values of the fractions are equal. So children, what I'll be doing is I'll be giving you some examples to practice wherein you have to convert the number into equivalent fractions. I'll be giving you some guided examples. Okay children, now next what we are going to do is we are going to learn how to convert a fraction into its lowest term. Converting a fraction into its lowest terms. Now this always we do when we solve certain sums in standard 9th and 10th, mostly algebraic sums, wherein you have to convert the fractions into its simplest form. Say we'll be doing one sum, reduce 56 upon 64 into lowest terms. Okay, so how are you going to convert 56 and 64 into lowest term? First, you will be looking at which is the greatest common factor of 56 and 64. So how are we going to find the greatest common factor of 56 and 64? To find the greatest common factor, you need to find the factors of 56. Okay, factors of 56. What are the factors of 56? The factors of 56 are, say 56 goes in the table of 2, it goes in the table of, I need to teach you the rules of what you call division. So if I teach you that, you'll find it very easy. It goes in the table of 2, it goes in the table of 4, it goes in the table of 7, it goes in the table of 8, then it goes in the table of 12, it goes in the table of 28, okay, then it goes in the table of 14, it goes in the table of 56. So these are the factors of 56. Now let's find the factors for 64. The factors of 64 are 64 goes in the table of 2, the last digit is even, so it goes in the table of 2. It doesn't go in the table of 3, it goes in the table of 7. Okay, so then it goes in the table of, it doesn't go in the table of 7, it goes in the table of 8. Then it goes in the table of 32. Then it goes in the table of 64. So children, if you'll have a close look at this, say to find the factors, you can divide it by 64 also like this. 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6 are 12. That means it goes in the table of 16 also. Then 2 8s are. Then it goes in the table of 4 also. Then it goes in the table of 2 that I've already written. So these are the factors of 64. Now you'll have to look what are the common factors, 2, 4 and 8. And in the highest common factor is 8. So what is my GCF here? My highest common factor is 8. So to reduce 56 upon 64 into its lowest term, I am going to divide the fraction by the greatest common factor. Now children, so what I'll do is I'll divide 56 and I'll divide 64 by 8. So 8 sevens are 56, 8 eights are 64. So the reduced form of 56 upon 64 is nothing but 7 upon 8. This is how you need to reduce. Say children, if you don't know how to reduce it, you can follow this step also. Say if it is 56 and 64, you write down the prime factors. Say 56, what are the prime factors? 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14, 7 1s are 7. So my prime factor, my prime divisors will be 2 into 2 into 2 into 7. Now coming to 64, you find the prime factors. 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9, 3 1s are 3. Okay, 2 3s are 6, then 2 2s are 4, 2 1s are 2, 2 18, 2 6 are 12, it's 16. Okay children, I'm very sorry. 2 8s are, then 2 4s are 8, then 2 2s are 4, 2 1s are 2. So here the front 2 into 2 into 2 into 2 into 2 into 2. So you have here this 2 getting cancelled. So what is left is 7 upon 2 2s are 4, 4 2s are 8, 7 upon 8. So even you can solve converting a fraction into its lowest term by this method. Okay, so if I'll give you some sums to solve, you have to do it children. Okay, so now next we'll be learning multiplication of fractions. Okay, so we'll be learning multiplications of fractions. Please make note of whatever is being taught to you. Multiplication of fractions. See children, say if there are two numbers, one is 2 by 5 and say the other fraction is 7 by 3. So what I'll do, multiplying a fraction, you multiply the numerator by the numerator of the fraction, you multiply the denominator and denominator of the fraction. So it's 7 2s are 14, 5 3s are 50. Then you try to convert this into its simplest form. You cannot convert 14 and 15 into its simplest form. This is the simplest form of the fraction. Okay, so say this is your first sum. Now second, how do you multiply a fraction? See, the question I'll take it as 3 by 4 and say I multiply it by 9 by 12. Okay, say this is the fraction. The first and the foremost thing that you have to do while multiplying the fraction is cancel out the terms. You will see that whether 3, see you can cancel the terms of the numerator and the denominator. You need to look out in which table does 3 and 12 go, or in which table does 9 and 4 go. That means you can cancel it in a cross way, or you can cancel it up and below, but you cannot cancel it by these sides. Okay, so this is 3 1s are 3, 3 4s are 12. Okay, so what I have is 1 upon 4 into 9 upon 4. You cannot cancel it this way, so this becomes 9 1s are 9, 4 4s are 16. So 9 upon 16 is the, I multiplied the numerator and I multiplied the denominator. 9 upon 16 is the multiplication of these two fractions. We'll be looking at few more examples children, so that it helps you. Say I have a fraction which is 5 by 6 and I have another fraction which I multiply, say it's 7 by 20. Now see children, first you look out whether I can cancel out the terms. Okay, say can I cancel 5 and 6? No. Can I cancel 7 and 20? No. Can I cancel 6 and 7? No. Can I cancel 5 and 7? Because according to the rule of multiplication, you cannot cancel two terms which are by these sides. Okay, but I can cancel 5 and 20. How I can cancel it out? 5 1s are 5, 5 4s are 20. So what I have left with me is 1 upon 6 and 7 upon 4. Now I multiply the numerator and I multiply the denominator. So my answer is 7 upon 24. Okay children, so this is how you multiply a fraction. So multiplication of fraction is also very important, because you definitely come through certain sums wherein you have to solve multiplying the fractions. Okay, so whenever you multiply a fraction, it is very much necessary that you simplify it to the lowest term. So that is one of the important thing that you need to remember. So now we'll be learning division of a fraction, children. How to divide a fraction. So my next topic will be division of fraction. Okay, so I'll write down division of fraction. So how do you divide a fraction, children? Say I have a fraction 4 by 9 and I divide it by 16 by 15. When dividing a fraction, first you look whether you can cancel out the numerator and denominator, whether you can simplify the fraction first. Can I simplify 4 and 9? No, I'm not going to simplify it. Can I simplify 16 and 15? No, I cannot simplify it. So when both the fractions cannot be simplified, you move on to the next step. The next step is you convert the division sign into multiplication. And when you convert the division into multiplication, 16 upon 15 becomes the inverse. Okay, so it becomes 15 upon 16. And now you solve by the rule of multiplying the fractions. You know that 4 can be cancelled. 4 1s are 4, 4 4s are 16. I cannot cancel 15 and 19. So I'll multiply it directly, 1 upon 9 and 15 upon 4. So this gives me 15 upon 9 4s are 36. So this is my answer. So this is how you divide a fraction. I'll solve one more sum for you, children. Say I have a number with me which is 72 divided by 96. Sorry, 72 upon 96 divided by 9 upon 144. First I'll find out whether I can simplify 72 or 96. Yes, I can simplify. It goes in the table of 8, right? 8 9s are 72. So I can write this 8 9s are 72. Then 8 12s are 96. So I have 9 upon 12. Again 9 upon 144. Can I simplify 9 and 12 again? Yes, I can definitely simplify it. It goes in the table of 3. 3 3s are 9. 3 4s are 12. So I have 3 upon 4 divided by 9 upon 144. Can I simplify 9 and 144? Yes, I can. How do I do it? See, 4 plus 4 is 8 and 1 9. So the sum of the digit is 9. That means it goes in the table of 3. So I can divide it. 3 3s are 9. Then 3 4s are 12. 24 is left. Then you have 3 6s are, sorry, 8 3s are 24. So you have 48. So I've converted into simplest form. So this becomes 3 upon 48. So now what I do, children, I convert the division into multiplication sign. And this becomes 3 upon 4 becomes 48 upon 3. This gets reversed. The inverse of it has to be written. Then I'll be cancelling out 3 and 3. What I left is 40. What I left with is 1 upon 4 into 48 upon 1. Again I can cancel 4 and 48. 4 1s are 4. 4 2s are 8. So my answer is 12. Okay children, I hope you understood this. So see how I have done. If you're not able to solve this way, the simpler way that you can solve the same sum is like this. Say you have 72 upon 96 and you have divided it by 2 by 144. Directly what you do, you convert the division sign into multiplication sign, and when you convert the division into multiplication, this is 9 upon 144, this becomes 144 upon 9. When division is converted into multiplication, the next fraction becomes its inverse. And now what you can do, you can directly cancel out the terms. You can see it goes in which table, and when you cancel it out, you can get the resultant answer. How you can cancel it out, children? See, it goes in the table of 8. 72 goes in the table of 8. 8 9s are 72. 8 12s are 12 1s are 12. 12 12s are 144. 9 1s are 9. 9 1s are 9. So what I have left with is 12. So this is also one way where you can solve the sums. I'll be giving you many guided practice sums, children. So you have to definitely solve it. Okay. Now, children, we'll be moving further and we'll be solving few more things. Addition and subtraction of the factors. And this addition and subtraction of the fractions we'll be doing it in the next lecture. Students, today I am going to tell you one of the tricks. And this tricks, you remember how to find the square of a number ending with 5. Square of a 2-digit number ending with 5. So this is very easy, children. Say I'll ask you, what is 15 square? And you know 15 square is nothing but 225. But say if I ask you suddenly what is 75 square, and you are stuck because you cannot remember the squares of big numbers. So whenever the ending digit is 5, how do you find the square of that number? Say 15. You know that 5 square is 25. Okay, this you write 5 as 25. Now which is the number next to 1? The number next to 1 is 2. So you multiply 1 and 2. 1 2s are 2. So your answer is 225. Say if it is 25. So 5 square 25, you write this. The last 2 digit will be, which is the number next to 2 is 3. 3 2s are 6. 625. Say if the number is 75. I'll write 25 here. Which is the number next to 7 is 8. 7 8s are 56. So the answer is 5625. Say I need to find the square of 35. And you know that 5 is 25. The number next to 3 is 4. 4 3s are 12. So it's 1225. This is one of the tricks where you can find the square of a 2-digit number ending with 5. Okay, children. I hope that whatever I've taught you would have understood. I'll be giving you guided practice so that you can solve it at your home. I'll be giving you many examples through the WhatsApp group that we have created. Solve it and send it to me. Have a nice day. Thank you. Bye.